Hey guys, welcome back to another Rust tutorial. In this video, we'll be talking about structs. Structs are very similar to tuples in that they both can contain multiple data types, but the difference between structs and tuples is that the values in structs can have a name associated with them. Let's take a look. We define a struct using the struct keyword, followed by the name of the struct that we want to give it. In this case, let's make a struct that defines a user. Then we'll open it up with curly brackets. And inside these curly brackets, we'll define the fields or the values that our user is going to have. Let's give our user a username of type string, an email of type string, a logged in counter of type U64, and an active or inactive status of type bool. Now that we've defined our struct, we can initialize it. To initialize a struct, we simply use the struct's name followed by curly brackets. Inside these curly brackets, we'll assign values to the fields of our struct, separated by commas. So let's print these values out. And we can access these values using the dot syntax. And we can see the values are printed out. But printing like this is kind of tedious. We can actually implement the debug printing to our struct. To do that, simply add the #derive debug. Rust allows us to easily implement the debug printing as long as all the fields in our struct also support the debug printing. In this case, since we're using all the primitives that Rust provides, they all support the debug printing. And now we can change our print to just print out user. And if we run our code again, we can see now we get our debug printing. Now let's see how structs work with functions. Let's make a function that creates a struct and returns it. It will take in a username and an email. And we'll have the login count and active with default values of 0 and true. Now we can change the code in our main function to make use of this function. And if we run our code again, and we can see everything's still working correctly. One shortcut that Rust allows us to do is if the field name in a struct and the variable name is the same, then we can remove the colon syntax and simply just put the variable name. Rust knows automatically to assign the variables to their respective field names. If we run our code again, we can see that it's still working. Another shortcut that Rust allows us to do is, let's say we want to create a new user, but this user is going to have a different username and a different email, but we're going to keep the same login count and active status from our original user. Usually we would need to do something like this. And if we print out our new user too, we can see that it has the same logged in count and active status, but it now has a different username and email. But this gets kind of tedious when we want to copy a lot of values from our original user. So Rust allows us to use the dot syntax. And this will copy over all the fields that we didn't initialize from user 1 to user 2. When we run our code again, we can see now we get the same output. Another thing that Rust allows us to do is we can have structs without field names. Here I have two structs that have 3 field values, but none of them have names associated with them. The initialization for these are a little bit different from normal structs. Instead of using curly brackets, we use round brackets, and we just put our fields one by one. And we can print these out. We can also have structs that have no fields at all by just having the curly brackets. And if we print it out again, we can see that now we just have a point with no fields. Now let's talk about methods and associate functions. Here we have a rectangle struct with a length and width. We'll start with the impl keyword followed by the struct that we want to add methods or associate functions to. In this case, we'll add to our rectangle struct. Then we have open and close curly brackets. And inside our impl block, we can write our associate functions and methods. Let's start with the associate function first. We'll write a function called new that takes in a length and a width and creates a new rectangle for us. And let's make a new rectangle using this function. And we'll print it out. And we see that the function worked correctly, and we return back a rectangle with a length of 10 and a width of 5. Notice how the function required us to prefix it with a rectangle : : This is because the function is associated with a struct. In this case, it's associated with rectangle. This way we wouldn't have conflicting function names because there will probably be a lot of function names with name new. Now let's make a method for our rectangle struct. This time we'll make a function called clone. It's going to take in the self keyword, which is the instance of our rectangle, and it's going to return a new rectangle. Now let's make a new rect called rect2, and it's going to be a clone of rect1. And we can print both of them out. And we can see that now we have two rectangles of the same values. Notice how this time we didn't prefix it with rectangle. Instead, we had an instance of our rectangle, in this case rect1, and we wanted to make a complete copy of our rect1 to rect2. Of course, this also works if you want to make methods that mutate on our struct. Let's say we wanted to make a method that changes the width of our rectangle. This time it's going to take a mutable reference to ourself, and it's going to take in a width. It's not going to return anything. And we're just going to set our width to be the new width. And now we can change our rect2 to be a mutable variable. And we can set our rect2 width to 20. And if we run our code again, now our second rectangle has a width of 20. And that's all for this video. In this video, I try to do a live commentary rather than a voiceover. Let me know if you guys prefer one or the other, and I'll see you guys in the next video.